Another type of word problem you might run into is a category of word problems called mixture problems. Anytime you're taking two or more quantities that have a different value or worth and you're putting them together, fits in this category. So this is a huge category of word problems. So we're just going to do a couple of them today. Let's start out with something like, let's see, a play sells, let's say they sell 100 tickets. Let's make it easy. Adult tickets. Tickets are, let's say, $10, and kids tickets are, I don't know, $7. A little bit cheaper, right? They're kids. All right, so let's say that we go to this play, and at the end of the night, we know they sold 100 tickets. We know the price of the tickets, and let's just say they made a total of, say, $520. How many of each type of ticket was sold? Okay, so we got this play. They're selling tickets. You got kids tickets, adult tickets that are different prices. So you see, we're going to be mixing two things of two different value or worth together, and we know a total for the evening. So can we figure out how many of each were sold? All right, since we're mixing things together, a table is always a good way to organize our information. Now, unlike something like our motion problems that we've seen in the past, the columns for this aren't quite as easy to name. Let's just call one of the rows adults, the other one kids. We have to be a little bit more generic on this. The first one's going to be an amount column. The second one's going to be a value or worth. And the last one's going to be a total column. I'll put a question mark right there because total what? Depending on the type of problem is what the total represents. So if we take a look at adult tickets, what do we know about them? Well, we don't know how many we sold. That's what the amount means here. That's actually what we're looking for. We do know their value or worth. They're worth $10, and we don't know what the total yet is. We'll figure that out in a second. For the kids tickets, we don't know how many kids tickets we sold, but we do know that they were worth, what did I say, $7. And we don't know what the total is here. But let's see if we can figure out the total. When we're doing these mixture problems, generally we take the first column times the second column to get our total. So if this is the number of tickets, and this is how much they're worth, so it's going to be the number of tickets times how many types of tickets, this would be the total amount of money made from that type of ticket. So like, here watch, if I had 20 adult tickets times $10, that means I would make $200 off the adults. So that's how we can figure out what our total is talking about. All right, so let's get rid of this because I actually don't know how many adult tickets I've sold. We need some variables, and since we're looking for how many, I know variables go in this column right here. So let's put an X in one of them because I have no idea how many adult tickets I've sold. How do I figure out what goes in this box? Well, I know there's a total of 100 tickets. So whatever goes in this box has to be the rest of them. So again, I'm going to remove this section. Let's just put a number here real quick. Let's act like we knew that there was 30 tickets, adult tickets sold. If there's a total of 100 tickets, how many kids tickets would that be then? Well, it would be the total minus ever how many adults tickets I've sold. So if we're going to do the same thing, let's just say I don't know how many adult tickets there are. Well, how many are left? Well, 100 minus whatever that was. Okay, so there's our variables. You can kind of think about this as the leftovers. Okay, so let's figure out our total. How much money did we make off the adults? $10 times ever how many adult tickets we sold. How much did we make off the kids? 7 times ever how many kids tickets we sold. All right, now the last column here, generally the total column, is what we're going to write our equation with. We still have a total for the evening. We know we made a total of $520, and that makes sense because our total is money also. So the amount of money we made off the the adults' tickets, plus the amount of money we make off the kids' tickets has to be the total amount of money we made for the evening. All right, so now from here, this is just a linear equation. I'm gonna leave it up to you to solve it. You might want to check me on this. I believe the answers to this are we sold 40 adult tickets and 60 kids tickets. You might want to check that though. So run through the algebra and see if you can solve that. All right, so this is one type of mixture problem. Let's try another one. I'm going to need some room here. I think I can fit it over there. So let's say you have $1,000 to invest. You invest some at, let's do 5%, and the rest at 7%. Let's see, we know after 1 year, you made $56 in interest. How much did you invest in each account? Okay, so a slightly different type of problem. These are generally called interest problems. And the idea is we have some money we want to invest and we want to split it between two different accounts. Now, a really good question would be, why in the world would we invest some at a lower interest rate and not all of it at the higher interest rate? Well, when you're investing money, generally if you get a higher interest rate for a return, that means it's more risky, which means there's a higher chance that you could lose money. So it's safer to invest at a lower interest rate most of the time. So you can see why you might want to split up your money a little bit, some into high risk and some at a low risk. All right, so notice we're mixing two different accounts together, so it fits as a mixture problem. Now this one's slightly different because we're actually using a formula that we've used in the past. We know interest is equal to principal times rate times time. If it is simple interest, which this is, even though we didn't come right out and say it. So we are going to make ourselves a box. Now, a little bit tricky. I'm drawing the exact same box I did last time. And we're going to do it just like our formula. Interest, principal, rate. Now notice I don't have a column for the time. I'm going to kind of do this. The reason is, for most of the problems you run into, time ends up being 1, so it's really irrelevant for most of these. But if time's not 1, you do need that extra column on there. Okay, so let's go. For one account, I don't know how much, let's start with the 5%. I don't know how much interest I made at the 5%. Let's just go ahead and label these 5%, 7%. I dropped some stuff. Oh, I don't know how much interest I made at 5%. I don't know how much I invested at 5%, but I know the interest rate, well, is 5% and the time was 1 year. Same thing for the 7%. Don't know the interest, don't know the principal, how much I invested, but the interest rate is 7%. All right, the question says, how much did you invest in each account? So we're looking for principal. So I know my variables go in this column right here. Again, let's just say I don't know how much goes in the 5%. So how much do I have left to go in the 7%? Well, it's the total, I'm gonna write kind of sideways here, 1,000 minus X, right? Exactly the same way as before when we had a total. Whatever you do for one, the other one has to be the leftovers. So we're trying to figure out interest here, and according to our formula, interest is equal to principal times rate times time. So the amount of interest we make at 5% is 0.05x. And the amount we make at 7%, again, I have to kind of write it sideways here, 1,000 minus x. So squeezing it in there, hopefully you can read that. All right, so now we got to write an equation. The interest is what we're talking about, and we have a total interest for the year. So the interest that you make at 5% plus the interest you make at 7% should be the total, what did I say? Total amount of interest was $56. All All right, so now again, it's just a linear equation. This does have decimals in it, so you may want to clear those when you get around to it. Again, I'm going to let you try this one on your own, practice those solving linear equations. Again, I think the answer to this one is at 5%. I believe it's $700, and then that would be $300 for that one. So go through, do the algebra, see if you can solve this, see if you come up with 700 and 300. All right, let's take a look at one more of these mixture type problems, and this one's a little bit more classical, I would say. Let's get this out of here. A little bit more room. I'll leave that there for a second. Let's see. Let's say you need 100 milliliters of a 30% acid solution. You only have a 15% and a 45% solutions. How much of each do you need to mix to get what you need? All right. So here's the idea. We're working in a lab or something like this, and we need 100 milliliters of a 30% acid solution, right? So when we finish, think about, we got some kind of like beaker here full of acid, so there's some acid in there. We don't want all the liquid to be acid. We only want part of it to be acid, and we want 30% of that to be acid. But the problem is when we went to our cabinet and we looked up acid solutions, we didn't have a 30%, we had a 15% and a 45%. So since 30 is in between there, we should be able to mix those together and come up with the 30%. So how do we do it? Well, again, this one's really obvious that it's a mixture problem because, well, it says, well, mix them together. So we're going to set up our table. Same way as actually our first table. Let's see. We have an amount. We have a value or worth. And then we have a total. Again, we got to figure out what the total is that we're talking about here. Now we're mixing two different solutions. What are we mixing? We're mixing a 15% solution and a 45% solution. So let's see if we can start filling out our table and figure out what everything is. Well, we don't know how much of the 15% solution we're going to use. That's actually what we're looking for, so we know some variables are going to be here. We do know that when we use that solution, only 15% of it is acid. So if you think about it, what would this total column be? If this is the amount of stuff times the percent of it that's acid, then this total one would be the total amount of acid that we're talking about. All right, same thing for the 45% solution. We don't know how much we're adding in, but we know only 45% of it's going to be acid. So we got to figure out the total amount of acid that we have. All right, we're looking for an amount. So just like before, I have no idea how much I'm adding there. But for the 45% solution, that has to be the rest of it. Well, I want a total of 100 milliliters. So whatever I add for the 15%, the leftovers has to be at the 45%. Go again, just like our first example, we do the first column times the second column. So 15% of ever how much we add of the 15% solution is acid, right? 15% of that is acid. 45% of this, so 0.45, a little bit more room here, so 100 minus X, that's how much acid we get from the 45% solution. So here we're talking about total amount of acid. So let's look. The amount of acid from the 15% plus the amount of acid from the 45% has to be the amount of acid we want in the final. So how much acid do we want in the end? Well, we want a total amount of stuff in the end to be 100 milliliters, but we don't want all that 100 milliliters to be acid. We want 30% of 100 milliliters to be acid. So 30% of the 100 milliliters has to be acid. Now, a quick little hint when you're dealing with percentages, percentages never go into a problem alone. You always have to do the percent of something. And remember, the word of in math means multiply. So 15% times X, or 15% of X, 45% of 100 minus X, and 30% of 100. Notice we have that multiplication each time. All right, so again, we ended up with a linear equation. You should be able to solve this. The answer to this is 50 milliliters of each. So 50 milliliters and 50. It's right in the middle, so you could expect the same amount of each. All right, mixture problems. They are a little bit more difficult on the scale of word problems. Set up your table, put the information in, and then write your equation. Once you finish writing your equation, and when we're doing most of these, you're generally going to end up with a linear equation. Follow your steps for solving a linear equation, and you should be fine.